For question number 2, we're going to continue in the same way. We're going to go ahead and start with drawing our barriers. Here we have our -2 and at +3. And we're going to look to do our transformations. So on our first piece here, I'm going to do that one in purple. We're going to think of that in our transformation form. So we're going to have our A of -1, H is -4, and our K is -2. So since it's a parabola, that gives us a vertex at -4, -2, like this. It has an A value of -1, so it's been reflected across our x-axis, but other than that, it's a normal parabola, so we can follow the normal pattern we typically do. When we hit the barrier, we're going to draw an open circle, connect up some points, and we've got our general parabola. Since we do have a less than here, we are going to leave that circle open. For our middle piece, this is a linear function, so we can do that as slope-intercept form, or you can make a table. Either way is just fine. I'm going to start at my y-intercept of 3 and take my slope of -2. When I hit the barriers, I am going to draw myself an open circle, so I can think about that in just a second. I'm going to connect them up. If you are on paper, you should use your ruler. My iPad's just super grumpy. My left-hand circle, we are going to fill in. That is a closed circle. And my right-hand circle, we are going to leave open. For our greatest integer function, that's when we think about our rounding down. So if it was between 0 and 1, we'd round down to 0. If it was between 1 and 2, we would round down to 1. So it's going to give us a step function. But then we're going to go ahead and take that step function and subtract 4 to move it down. So normally we're thinking about between 3 and 4. That's what this piece is, between 3 and 4. Between 3 and 4, it would round down to 3, but then we have to take away 4. So it's going to be at -1. Between 0 and 4, or between 3 and 4. So between 4 and 5, we would normally round down to be 4. Then we take away 4, so it's going to be between 0, or going to be on 0, between 4 and 5. Between 5 and 6, it would normally round down to be 5. That's going to put it at 1 when we take away 4. And the left-hand circle is filled in, and the right-hand circle is open. That one just kind of looks really blurry. Between 5 and 6, it normally rounds down to be 5. And that's the one we just did. Between 6 and 7, it normally rounds down to be 6. Take away that 4, and we get down to 2 here. And we can start to see our step pattern forming. For our domain, we can look at this and we see it's really consistent across the board. We don't have any gaps in our x values or anything like that, so it's going to go from -infinity to +infinity. Our range, we have a big chunk of our range from -infinity all the way up to the top of my blue line here, which is going to be a +7, and that value is included. Above that, it's going to be that greatest integer function, which is going up by steps, so it's going to be things like 8, and then 9, and then 10, and so on and so forth. So we're just going to put a dot, 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 close it, and call it good. For our discontinuities here, we have a jump discontinuity at x equals -2, and we have a jump discontinuity at x equals 3. And then we have continual jump discontinuities at every number, every whole number bigger than 3. I'm not going to ask you that on the test. That's going to be such a jerk move to ask you the discontinuity on a greatest integer function. I just want to talk about that for a second. Okay, so when x is greater than 3 at integers, or at whole numbers, because at this point it's the same thing. Oop, I'm supposed to spell it right. All right, so I'm not going to ask you to name the discontinuities on a greatest integer function. It's just good practice for us to do it here on the review. Okay, so that is question number 2.